Betelgeuse's impending stellar death is one of the most anticipated cosmic events of our time. When this massive star transforms into a supernova, it will shine as brightly as the full moon and even be visible during daylight. However, the exact timing of this cataclysmic explosion remains unknown. After experiencing mysterious fluctuations in brightness, Betelgeuse was once thought to be on the verge of collapse, only to recover. But now, the star is once again capturing attention, with unusual light variations. A new study suggests that the shoulder star of Orion could explode much sooner than previously expected. Back in 2019 and 2020, Betelgeuse made headlines due to a dramatic drop in brightness, which some experts interpreted as a sign of an imminent supernova. The explosion of this colossal celestial body would indeed be a breathtaking spectacle. Situated just 650 light-years from Earth, Betelgeuse is a red supergiant approximately 800 times the diameter of the Sun and shines 10,000 times brighter in visible light. As one of the brightest stars in the night sky, the sudden dimming that began in October 2019 left astronomers puzzled. Betelgeuse's usual brightness is estimated to range between 0.3 and 0.4 magnitudes. To provide context, the term magnitude, or mag, refers to the apparent brightness of a star, independent of its distance from Earth. The lower the mag value, the brighter the star appears. During the dimming event, Betelgeuse's brightness dropped to 1.1289 mag, while its temperature decreased by approximately 100 degrees C. This decline was so pronounced that it was visible to the naked eye, causing Betelgeuse to slip to 21st place in brightness among nighttime stars. Why do astronomers associate such fluctuations with an impending supernova? First, Betelgeuse has reached the final stage of its life cycle as a red supergiant, which inevitably ends in a powerful explosion. Second, significant expansion combined with a drop in brightness is often a sign of a star nearing collapse. However, this is where the uncertainty lies. No precise observations of supernovae exist prior to their explosion. Scientists still don't know whether a star dims years before its explosion or just hours prior. What is certain, however, is that Betelgeuse has not yet vanished. When Betelgeuse finally does explode, it will shine as brightly as the full moon for weeks. The event would be so luminous that other nearby stars would be almost impossible to see. As the brightest supernova ever recorded and the closest to Earth, its explosion could even be visible during daylight hours. A major drop in Betelgeuse's brightness over the past 2 years has raised new questions. If the dimming 5 years ago was not a sign of an imminent explosion, what caused it? The answer: dust. Observations with the Hubble Space Telescope revealed that a massive plasma eruption formed a vast dust cloud, obscuring nearly 2/3 of the star's light. While Betelgeuse frequently ejects stellar material, this particular event was exceptional. A combination of strong convection and expansion likely caused the plasma eruption to be 2 to 3 times more powerful than usual, resulting in a mass loss 30 million times greater than that of the Sun. After this event, Betelgeuse gradually returned to its original brightness. However, it has continued to display erratic behavior. In 2023, its luminosity increased significantly, only to drop again a few months later. While the latest dimming was not as extreme as in 2019 or 2020, it still marked the lowest brightness recorded in 2 years. This raises the question once again: could these changes signal an impending supernova? The answer remains uncertain. No expert can say with absolute confidence whether Betelgeuse will explode tomorrow or in a million years. Interestingly, it's even possible that Betelgeuse has already exploded, and we are simply waiting for the light from the event to reach Earth. A 2023 study suggests that the star may go supernova much sooner than previously expected. Researchers from Tohoku University in Japan analyzed Betelgeuse's pulsations and uncovered surprising evidence suggesting that the star is much older than once thought. As Betelgeuse's outer layers pulse, its brightness varies in relatively predictable cycles. The two most notable cycles last 2,200 and 420 days, respectively. Until recently, Astronomers assumed that the shorter cycle represented the star's heartbeat, indicating that it was a relatively young celestial body. However, if the longer 2,200-day cycle is actually the primary pulsation, Betelgeuse is larger than previously believed. Instead of being 800 times the Sun's diameter, its actual size could be 1 to 200 times greater. This would also mean that Betelgeuse is further along in its life cycle and approaching its supernova phase much sooner than expected. So, will Betelgeuse explode soon? Stars shine because they fuse hydrogen into helium at their cores. Once hydrogen runs out, they begin fusing helium into carbon, and as they age, heavier elements are formed. The Japanese research team used computer simulations to model how massive stars evolve from birth to their final stages. Their findings suggest that all of Betelgeuse's pulsations correspond to a much later evolutionary phase, the carbon-burning stage. According to their study, a core collapse leading to a supernova could occur just a few decades after the carbon supply is depleted. This time frame is significantly shorter than previous estimates, which suggested Betelgeuse's explosion was still 100,000 years away. However, these findings are not without controversy. Astrophysicist Morgan McLeod argues that the data does not align with other studies of Betelgeuse. Specifically, if the 2,200-day cycle truly represents the star's main pulsation, its calculated size would be too large compared to current models. Thus, some doubts remain regarding the new conclusions. There is also another intriguing possibility. Betelgeuse may have a companion star that has remained undetected for thousands of years. Recent analyses have revealed anomalies in the star's brightness fluctuations. Researchers at the Flatiron Institute in New York found that the 2,200-day cycle follows a different rhythm than the shorter 400-day pulsations. However, they found no evidence linking this variation to stellar rotation, magnetic fields, or convection currents. This led them to a fascinating hypothesis: the presence of a smaller companion star. If this is true, the periodic dimming of Betelgeuse could be caused by its companion moving behind it from our perspective. When the companion star is positioned beside Betelgeuse, their combined luminosities increase, reaching maximum brightness. Additionally, this secondary star could act as a dust shifter, influencing the distribution of surrounding dust clouds and further contributing to Betelgeuse's brightness changes. Why has this companion star remained undetected? The answer likely lies in its low mass. Scientists estimate that it weighs just 1.7 solar masses, almost 12 times less than Betelgeuse. Moreover, it orbits Betelgeuse at a relatively small distance of just 2.43 Betelgeuse radii, making it nearly impossible to distinguish against the immense brightness of the supergiant. The fluctuating luminosity of Betelgeuse further complicates the detection process. Despite these challenges, astronomers remain hopeful that large telescopes will soon provide definitive evidence of this hidden stellar companion. Determining its nature could unlock new insights into Betelgeuse's erratic behavior and its eventual fate. And with that, we come to the end of this cosmic mystery. If you enjoyed this exploration of Betelgeuse's potential supernova, be sure to like and subscribe so you never miss an update. See you in the next video.